Oh, a little music here to get us started off. Julio Iglesias and Willie Nelson. We'll shut it off though. Okay, going on to topic 2, linear functions. We're going to be dealing with slope, graphs, and models. To start us off, we're going to take a look at the slope-intercept form of an equation and then some word problems toward the end. But let's look at 1 through 4, which are key terms. We mentioned these in class, and we'll pause while we fill them out. Before we continue, I'd like to bring your attention to these equations that I have up here that I'm calling equations 1 through 6. And I would strongly suggest that on an index card you write these down. And through the course, particularly chapter 2, we'll be adding a few more. But I like to refer to these as equation 1, standard form of the linear equation in 2 variables, x and y. Equation 2, slope-intercept form, and you'll see why it's called that in a few moments. 3 is the formula for slope, and we'll be going over that a little later in this lesson. And then in a future lesson, we'll use equation 4, which is called the point-slope form. And that's y minus y sub 1 equals m, and then in parentheses, x minus x sub 1. And then here are 2 special equations, y equals b, and we'll go over that. And that's we'll call equation 5. And then equation 6 is x equals a. All right, so this is sort of background. I'll probably have this on the board for each lesson that we do in chapter 2 that relates to graphing. These are our references. And now for the key words. So an equation that's written in this form, that's equation 2, is the slope-intercept form. Now, a linear function, we can make this into equation 2 into a linear function by just putting where the y is f of x. F of x equals mx plus b. That would be in linear function notation because of this. And often we say the y can replace the f of x. Now, when we're looking at the m in this formula, that is the slope of the equation. Whatever's the numerical coefficient of x, that is the slope. And in this position where we see the b, and we had mentioned that in the previous chapter too, but now we're going to use it, b is referred to as the y-intercept. It'll be that point along the y-axis where the line of the graph will cross the y-axis. That is, intercept the y-axis. And that point is given by the letter B. Now, as we go through this, we're going to be showing you various graphing techniques. One that we used previously in chapter 1 was to make a t-chart. And these were our common choices for values of x, a -1, a 0, and a 1. Could you use other values here? Yes, but these are often ones that are selected. So remember, we could put a y there. And if x is a -1, this will be -2 times -1 gives you a +2, plus 3 is 5. Now, if x is 0, -2 times 0 is 0, so this becomes a 3. Now here, if x is a +1, a -2 times a +1 is a -2. A -2 and a 3 is a 1. Now we have our 3 points, so we're now going to plot them. -1, 5 is right there. 0, 3 is right there. And 1, 1 is right there. Now we take our line tool and connect the points. And you see it makes a nice straight line. Are there other points along that line? Remember, we said there were an infinite number of points. We could put an arrow on each end if we like. Now, an interesting thing to note as we go here, we said that this was the slope and this was the y-intercept. So we went y equals mx plus b. So there's our slope, -2, and there's our y-intercept, a 3. And we had said earlier that we indicate the y-intercept by 0, b. This is the official way to indicate the y-intercept. Now we also have an x-intercept here that we're not plotting, but it happens to be a 1.5, 0. And that was in the form of a, 0. That was your x-intercept. This is your y-intercept. And there is technique for graphing. We'll be introducing another method shortly. Now, as we go on to example 6, we've made our t-chart, but notice this time I didn't put in a -1 and a +1. I put in a 3. And you might say, why did I do that? Well, take a look at this. When I see my slope is a fraction, in order to get nice whole numbers, it's always good to use multiples of our denominator. That will make this a whole number. So watch, when I put in a -3 there, the 3's will cancel out, and I'm left with a -1. So 2 times -1 is -2, and a -1 add up to a -3. And we always use 0, because anytime that your x is 0, remember, x is 0, whatever is in that position, which is your b position, that's your y-intercept. So that will be a -1. And then now if this is a -1, or I should say a negative, in this case a +3 there, this is going to be a +2. The 3's will cancel out. I'm left with a +2 minus 1 makes this a 1. So when I plot these, -3, -3 is right there. 0, -1, notice this is your y-intercept right there. And 3, 1, 3, 1 right there. And then you put your line. Now, notice even that I'm having a straight line here, I'm missing this point a little bit, and I'm missing this point a little bit. So when you do your graphing using MATLAB, it's going to be very accurate for you. And we will be providing you during tests with some sort of straight edge that you can draw nice straight lines, because that will be critical in some cases. But right now we're sort of sketching, and I don't really have a ruler. I have a straight line, but I don't have a ruler to really line these points up. Okay, let's go over to the next one here. And what we're doing is we are going to determine, by looking at this equation, which is in slope-intercept form, that's equation 2, what is my y-intercept here? Well, our y-intercept we said was b, and this is what's in the b position. So our y-intercept here is 5. Now this is one way to write it. You can say b equals 5. But the true formal way to write it is to put that 0 in there and give it as an ordered pair. Remember, when it's 0, b, 0, b, that is your y-intercept. And your y-intercept for 8, again, it's in function form, is going to be a negative 17. So 0, negative 17, and that's an ordered pair. That's your y-intercept. Now on a test, I'll usually accept it in either form, just the y-intercept or in its proper form. Now what they're not asking you here, and it's something I could ask, what would be your slope? Well, your slope here is the numerical coefficient of x, which is a negative 2. And here the slope is a positive 4.1. So whatever is in the m position on equation 2, that is your slope. Remember, lowercase letter m is how we designate slope, and we still have some things to learn about that. Okay, now as we look at these, this is our basic slope formula. This is formula number 3. And it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So what I like to do is to designate the second set of ordered pairs as your sub 2's. So this is your y sub 2, which is a 6, and then minus is in the formula 3. 6 minus 3. Then our x sub 2 is 1 minus, now minus is in the formula, but it's a minus 2. So you have to put that in parentheses because something's going to happen here. The opposite of a negative will make this a positive. So this is going to be a 3 on top over 3 on the bottom. So our slope here, and I could put a letter m out there, is going to be 1. Now really it's 1 over 1, but we just write it 1, but it's 1 over 1. Okay? Now as we do these others, they're going to take a little bit of calculation. I'm not going to leave the tape running because it's going to take too long. But notice we can do some changing of signs here. So a negative 1 minus a negative 1. So minus a minus, this is going to become a plus here. And I see now my numerator here is going to be 0. And this is going to become a plus here. So my denominator becomes a negative 3. Any number in which you have a 0 in the numerator divided by any number that's not a 0, here the answer is 0. The slope is 0. And that's a good number. Now, for this one, we're going to have common denominators. And this one we have fractions. But notice, because of the negative and a negative, these are all going to, this is going to become a plus. This one doesn't. But this one's going to become a plus. And this will become a plus. So we'll figure these out and get back to you. Okay, dealing with some fractions. Here our common denominators are 10 there and a 10 there. So we have to make these equivalent fractions. Multiplying this by a 5 and a 5, that gives me a negative 15. And 5 times 2, or 2 times 5 is 10, so 2 times 2 is 4 over 10. And this becomes an 8/10, and that's just a regular, no negative there, minus 5/10. So this will give me 3/10. This is a negative 11/10, which is a negative 11/10 divided by 3/10. I change it to multiplication. Flip this. The tens cancel out, and I'm left with a negative 11/3. And this one, when I do what I need to do, I end up with a 0.5 over 1. And I don't know if you can see that that is, if I multiply this one by 10 and this one by 10, it's 5 over 10, which is 1/2. Okay, as we go on to number 13, they're asking us to determine the slope and the y-intercept, and then using these two items to draw the graph. Well, remember, whatever's in the M position is the slope, and whatever's in the B position is the y-intercept. So our slope here is going to be 3 over 2, and our y-intercept is going to be negative 5. Now, this is an easy way to graph. So watch what I'm going to do. And by the way, a little background on slope again is slope is a ratio of rise, which are y units, over run, which are x units. And you'll see as I show you. So the first thing we do is we plot the y-intercept, which is negative 5. Now from this point, we're going to plot a slope that is 3 over 2. Now since it's positive, the way I like to do this is I will plot my x units, and I mentally make a little right triangle. I'm going to go over 2 units right there. And now that's my run, positive run from the y-intercept. Now I'm going to do my rise, which is 3. 1, 2, 3. And I now take my line and I draw it right through there. And there is the graph. So my y-intercept is negative 5. My slope is 3 over 2, where this is the run. It's positive, so I'm going to go over 2. And then my rise, up 3. There's my second dot. Now when you put this in MATLAB, you put a dot there, and then you kind of do this mentally, put a dot there, and then the line forms. Let's try another. Now, when we see something like this, the form of this particular equation, it's equation number 1. This is in standard form. So what we want to do is to convert it to equation 2 by solving for a positive y. Again, there's different ways to do it, but what I would do here is I would just transpose the y to this side, and on this side it would become positive. Taking the y to this side, transpose the 4 to this side, it becomes a negative 4. And I have then the 3x stays there. So I'm just taking the y term, transposing it to this side, it becomes positive. Now, if you want to write it the other way, y equals 3x minus 4. That's perfectly legal. Now remember, your slope is 3 over 1, and your y-intercept is a negative 4. So the first thing we are to do is to plot the negative 4. We go down here and plot our y-intercept, a negative 4. Now again, this is positive, so 1 is my x, or run, and my rise, or y, is 3. So I go up 3. I make a little right triangle. Run, rise. 3 over 1. Then get my line, and there I go. And there's my graph. Should extend it all the way down. I'm a little off on that one here. Okay, but anyway, you see the technique. When it's in standard form, equation 1, we solve for y, put it in equation 2. We want a positive y, because once we solve for a positive y, whatever the coefficient of x is, that's our slope. And then in this position, that's our y-intercept. Now again, this one is in standard form. This is formula 1. Standard form. I want to solve for a positive y. Now my y is already positive, so I'm going to take my x term, bring that over, transpose it. It now becomes a negative 4x plus 6. And to get y by itself, I'm going to divide everything by 3. And I now get a positive y equals a negative 4/3 x plus 2. I now have identified my slope now as a negative 4/3 and my y-intercept as a positive 2. So the first thing I'm going to do is plot the y-intercept, a positive 2. Now from that, I'm going to do my slope. But now this is negative slope. So I'm going to take the x terms and go 3 to the left. This is negative. And now I'm going to do my rise of 4. 1, 2, 3, 4. And there's my other point. I've made a little right triangle. Get my line. And then just draw it right through there. Okay, so 3 over to the left, 4 up. Now you'll notice, and you haven't done too many, but generally speaking, well, this is always true. If a line starts low and goes up like so, this is positive slope. If a line starts high and comes down, as you go to the right, this is negative slope. So here we see that is negative slope. It's a way to double check that you have the right kind of slope. If it starts low, as you go to the right and goes up, that's positive slope. If it starts high as you go to the right and goes down, That's negative slope. Now, as we look at example 16, and remember we can always substitute a y for the function notation, we see that our slope is a negative 3/4. But there isn't anything in what the B position would be. In a sense, the B position, there's nothing there. So it would be 0. But that tells us something. Since the y-intercept is not there, it's 0, our graph is going to go through the origin. And it's from the origin, then, we plot the slope. Now notice this slope is negative. So I'm going to use my x term and go 4 units to the left. And I'm going to do 3 units of rise. And there is my graph that goes through the origin. Like so. Okay? And it extends this way too. And there are arrows at the end. So, because this is negative slope, I'm going to do my run to the negative left and then rise up. If it were positive, I would have done the run this way and up. Notice it's starting high and goes down as you go to the right, indicating its negative slope. And since there is no y-intercept listed, it goes through the origin. The y-intercept is 0. Okay, these next few are actually pretty easy because what they're telling us to do here is to find a linear function whose graph has a given slope and a y-intercept. So we will say the function of x is such that the slope, which is 2/9, we put the x in there, and plus 6, which is our y-intercept. So here, the function of x is such that a slope is -3. We have to include the x, and our y-intercept is -4. So the slope, again, function of x, is such that our slope is a -3/5 x, and our y-intercept is a -1/4. And we can almost see this next one down here, and that is f of x is such, our slope is 5, we put in the x, and our y-intercept is 2/5. So again, if we were going to plot any of these, we would plot the y-intercept first, and from that point, we would then draw the slope, doing run, if it's positive, to the right, negative to the left, and then up the number of rise units. Okay, for number 21, it says for each graph, find the rate of change. Remember to use appropriate units. So what I've done is I've made a little red triangle over here. So our run is 60. Now note our rise is from 1 to 5. So there's only 4 units of rise. And that, remember, is negative since it starts high and goes down. So that's a -1/15, which we could say then it's a decrease at 1/15 miles per minute would be the answer here. So as you spend time per minute, you decrease the distance 1/15 of a mile per minute. As we look at example 7, again, I've made the red line. This is 10, 20, 30, 40 years for run. And then going up from 11 to 15, that's 4 years. So 4 over 40 is 1 over 10. 1/10 pound of fish per year is the amount of fish that people are eating. And as time goes on, they're increasing the amount of fish because we say that that's healthy. Okay, for example 23, we have a plane that after an hour and 40 minutes of a total flight time of 2.5 hours starts to descend. What would be its rate of descent? Well, for how long is it descending? Well, we subtract 140 from 230. Remember, there's 60 minutes in an hour, so that gives us 50 minutes. Well, 200 or 20,000 feet, and it's 50 minutes, gives us 400 feet per minute is the rate of descent. Okay, we've done a lot in this chapter, so this is going to be our last problem. We're not going to go on with these. The answers are in your little booklet, but for this one, how do we figure it out? Well, Rachel walked 360 steps in 3 minutes. So we always put the minutes first, comma 360, that's an ordered pair. Then the other ordered pair would be up here, I think it's, if I can get to it, 12, 180. And we set that up in our slope formula, and we get 1440 over 9, which gives 160 steps per minute. But what they were asking is steps per hour. So we had to multiply that by 60 minutes, and that gives us the number of steps per hour. Wow. It really picks up there. It helps with the weight control and all the rest here. Okay, well, again, lots of stuff. The others are applications, but we're going to go lightly on that. You folks, if you've been following this, have been doing lots of good work.